Hi, everybody. It's a pleasure and honor to have the opportunity to discuss about the science of aging reversal amid these COVID-19 issues. And just to start, because COVID-19, by definition, is an infectious disease. However, it is very much prone to senior citizens. So in a sense, it's also related to the aging problem. Okay. So anyway, with that, let us start. Okay. So my talk will be organized as follows. In the beginning, I would present to you about some of the background and the hallmarks of aging. And after that, we'll be discuss about the history of the heterochronic parabiosis. And after that, we'll be discuss some of the clinical developments. And some of you may be familiar with our work from the past. However, recently, especially over the past 3 to 6 months, there are very a lot of progress has been made. Okay, and I think all of you will be surprised and interesting about the recent progresses. And with that, then we'll discuss about something called biochemical plasma exchange, and followed by our longitudinal results, which is we have some cases which have been followed for up to 2 years by this time. Okay, and after that, we will give you a brief summary from the top down again, and finally, we will present to you some of the business opportunities and the what is our future plan in this biomedical plasma exchange. And thanks for Suho for introducing me. And my background is actually physical chemistry, which is a bit different from most of the doctor. They are mostly biologically biology or biology related majors. So the way I look at the aging problem maybe is from a little bit different angle from most of the clinicians. And I received my trainings in the University of Chicago Medical Center, and after that I went to University of Pennsylvania, where I began the first lecture in anti-aging in UPenn back in 1994. So as a result, I think I'm one of the most senior people who is involved in the anti-aging medicine. And I think I'll present to you the history and development of this very exciting and interesting field. So let us start by looking at the peak of the death of the age of American woman. And this graph, the dashed line shows the x-axis is the age at death for US women, okay? And the dashed line is year 1933. And the solid line is year 2014, okay? And in this interesting slide, we can see there are three important aspects of it. The first one is you can see that from 1933 to 2014, the rate of death at birth is reduced dramatically, okay? Due to the improvement in obstetric medicine, okay? The second one is that the peak of the death is shifted from around 75 years old to around 90 years old, okay, over the past 80 years. And the third interesting aspect of it is the maximum, although the mortality rate at birth and the age of death has improved. However, the maximum lifespan is pretty much stayed the same. So with that given, unless there is a dramatic change in technologies, we are facing constraints on these three things. So let us look at the issue from another angle. Okay, this is the number of disease at different age bracket. So you can see that if by age of 60 to 64 bracket, there are only about 1/3 to 1/4 of people who is disease-free. And in other words, about 2/3 to 3/4 of the people is actually will have at least one chronic disease. By the age of 80, you can see that 90% of the people will have some chronic disease, from 1 to about 8 disorders. And it's only less than 10% of people will be living healthy by the age of 80, okay? So with that two slides in the background, what we are seeing, we can look at life as you can separate into two stages. One is the age before the 65, which is the common age of retirement, and which is pretty much disease-free, and people usually have a pretty healthy body, and we can say the health span is around 65 years old. However, after the retirement age of 65, you can see diseases such as cancer, coronary artery disease, diabetes, and even COVID-19. The rate of death will rapidly increase. So in other words, that before the retirement age, people are living healthily, and after the retirement age, people basically are living in poor health. So with all those background in mind, since the maximum lifespan is not likely to extend over the next few decades, so what we are seeing is recently, over the past 10 to 20 years, there is a paradigm shift in medicine. Instead of keep on prolonging lifespan, there is a lot of more emphasis in increase the health span. In other words, that people are trying to live healthily as long as possible, rather than live just in poor health for a prolonged period of time. So the philosophy becomes very different. So since aging is causing so much disease, so there are hundreds of diseases which is associated with the aging. So in around 2013, is a group of scientists and the physicians. They think that because the aging is such a complex problem, and people, instead of treating hundreds of different diseases, people are thinking about maybe we can find the root cause of the aging and try to manage this diversity of diseases in a different way. So in other words, people are trying to find out around 7 or 8 fundamental aging problems, and which is causing the aging-related disease. And quoting Judith Campisi, who is one of the people who is in the panel who structured the hallmarks of aging, she always says that instead of treating hundreds of diseases, if we can manage the aging or hallmarks of the agings, then will be much easier. Okay, so let us look at quickly about the hallmarks of aging. You can see some familiar terminologies here. You see the genome instability, you see the proteostasis, and you see the nutrient sensing, mitochondria, cellular senescence, stem cells, exhaustion, and altered intercellular communication. And some of these terminology becomes so familiar in the marketing of supplement industries. So you can see a lot of companies just take out one or two words from these hallmarks of aging and just begin to develop in their commercial products. And I think as a physician or as anti-aging doctors, I think we are aiming at more than just selling supplements. So we are become more interested in solving the aging problems using medical technologies. So there are about 8 hallmarks of aging. However, all the hallmarks of aging are also related. Okay, and after years of research, I think we can restructure the hallmarks of aging in a causal relationship. So from this picture, we can see the root cause is pretty much just 2 things. It has not been changed since 1994, when I was teaching anti-aging medicine in University of Pennsylvania. There are two ways, there are two theories, or there are only two reasons that aging occur. One is genetic and one is epigenetic. And genetic means that if your father or mother both live to a long age, and then basically you have a longevity gene. So the chances that you will live to 100 years old will be much higher. And you can see that that was pretty much a situation in Japan and in Southeast Asia and in whatever, most of the part of the world is genetically related. The second type of cause of aging is called epigenetic. That means that that's environmental causes. That's after the people is being birthed, and then if you live in a different condition, that can definitely affect the lifespan of the individual. So, and if we don't consider the lifestyle of people, it is that, but everybody needs to breathe, right? So after, if you, as long as breathing, then there are going to be any energy expenditures. So as a result of all those TCS cycles, all the NAD, NMN, all those biomolecules, in order to sustain life, then there are certainly some type of reactive oxidative species. Some of the free radicals are going to be produced from all those energy systems. With those free radicals, then you are going to cause some macromolecular aggregations. So that because free radicals has a much shorter half-life, and it will also increase the reaction connection and chemical bonding of those large molecular cause. And after those macromolecules begin to aggregate, then you are going to have some organelle malfunction, and that's commonly known as the mitochondrial dysfunction. Okay, so and after that, the cell, because within the cells you're going to have some of the macromolecular aggregations, which comes with the dysfunction of the mitochondrial endoplasmic reticulum. And since that, then the cell will enter a stage called cellular senescence. And if the cell doesn't enter this stage because of the above conditions, the cell may become oncogenic. So the cellular senescence is actually a protective mechanism for the cell against the cancer. Okay. However, this process does not go on forever. The senescent cells will secrete some chronokines, which will affect the function of the adjacent stem cells. The stem cell affected by those chronokines secreted by the cellular by the senescent cells. The stem cell become dysfunction. As a result, they cannot repair the trauma of the tissue. So and eventually you're going to have a tissue fibrosis from chronic injuries. And at the same time, the stem cell stop to the regulation function of the stem cell will also decrease. As a result, you are going to have a condition called chronic inflammation. So these two things, what comes after these two preclinical stages of changes, then it will be many state of disease. Okay, so this is basically the causal relation picture or diagram of the hallmarks of aging. So aging is a very complicated problem, and as a scientist, we want to solve the aging problem. So we want to find a root cause, or try to come up with some anti-aging theory, so we can approach or manage the aging problem or aging-associated disease in a more effective way. And let us review what's the definition of science, okay? And here are the definition of science. One is you are going to observe something, then you come up with a hypothesis. And with that hypothesis, you need to design some type of experiment. And the experiment, the experimental results should be able to be reproduced. Okay, if it's just one people can do the experiment and the other people cannot reproduce it, then we will not call it a scientific report or anything like that. So, and I think based on my understanding, here is a lot of clinically related medical doctor doing today's audience. So you will see that a lot of time when we are doing our practice, we forget about what is the definition of science. Usually we'll keep on trying to mingling around all these complicated pathways and things like that, and without any observations or hypotheses. So in the principle, the main purpose of today's talk is I want to try to discuss with you the aging problems from a more scientific aspect of it. Okay. So Judith Campisi, again, a very eminent anti-aging scholar. She always said the dirty nature of biology. So usually prevent us from approaching the aging problem or obtain any solutions, any clean-cut solutions. Okay, but is that really the case? So fortunately, due to the recent advances in a lot of the technologies, and today we are able to approach the aging problem with a more fundamental theories and mechanisms. So this is one of the most important paper on aging published, and it was published about 6 weeks ago in Nature. Okay, so the picture discusses about the energy expenditures throughout our lifetime. So the x-axis is again the life. So this is the children stage, the puberty stage, young adult, the usual adult, and the begin senior citizens. So you can see the energy expenditures actually it can be classified into 4 stages, and with 3 different inflection points separating these 4 stages. One is the pre-puberty stages, and the second stage will be the young adult stage. And contrary to most of people thinking that the energy expenditures will begin to decrease after the adult stage from 20 to 60 years old. Based on their study, the energy expenditure from 20 to 60 years old is actually remains the same. So a lot of people, they usually come up with an excuse that says for 50 years old man who has diabetes and who is overweight, usually the best excuse is because my metabolism becomes slower. That's when I begin to gain weight, and this is basically rule out this excuse. So the energy expenditures before the 60 years old in the adulthood basically stay the same. Once the energy expenditure begin to decrease after the age of 60 years old, you can see the disease incidence, all the chronic disease incidence begin to rise very quickly. Okay, so this study tells us the root cause of the chronic disease actually is very strongly correlated to the decline in the energy expenditure. And based on the first law of thermodynamics, that's called energy conservation. Okay, so we can see we can summarize what those people publish in this simple table. So when you are below age of 60, the energy intake and the energy outtake is pretty much about equal out. So there are no excess energy resulting. So when people become more than 60 years old, if you are taking same amount of calories or energy intakes, then the energy expenditure begin to decrease. So in that situation, you're going to have an excess of energy in the system. And what will happen is, once you have the excess energy in the system, then you are going to have a lot of extra chemical and unnecessary chemical reaction happens. And that's the root cause of the hallmarks of the aging. So in other words, if you are more than 60 years old, then your energy expenditure begin to decrease. Then if you don't make some changes, then you're going to have too much energy, and that will result in some of the disease in this system. So with that given, there are 2 very simple ways to correct this situation. The first one is called fasting. So if you fasting, by definition, just decrease the calorie intake. So if you can decrease the calorie intake by about 30%, 30%, then you can correct the excess energy. It will equals out, because with the same amount of energy being spent, then you're going to have a net zero of excess energy. And the other way is doing exercise. So if you do take in the same amount of calories per day, and if you begin to do exercise, increase your exercise amount to increase the energy expenditure, then again, you can have a zero excess energy. In that case, you will not enter the aging stage. So this is the reason, regardless of all these advances in science like stem cells, fasting, mitochondria, cellular senescence, and NMN, NAD. So the dieting or fasting and the exercise remains the best way to stop the aging procedure. And there are numerous thousands of studies supporting this argument. And with this recent publication in Nature, also explains why dieting and exercise are this way, or are the best anti-aging methods. Okay. However, this dieting, you need to cut down about 30% of the calorie intakes. So if you want to live longer and by eating a little a day, or doing exercise, a lot of exercise per day, then you really don't need any other anti-aging method. However, all those three things usually are very hard to maintain. Okay, so what we see, instead of a lot of healthy individuals doing exercise, what we see is something like is people spending most of their lifetime dieting and exercising in an intermittent fashion. If you're dieting and the exercise in an intermittent fashion, you are not going to get the benefit of both. Okay, because after dieting, then you overeating, so the energy expenditure will begin to decrease, and you're going to have an excess of energy and cause a lot of problems. So you see people like this. I'm sure they are very conscious about their physical health, and you will see people try to diet, over several months, begin to eat and then exercise for half a year, then stop exercising and come back again. And you see this on and on. Okay, so these are very difficult to maintain. So since diet and exercise are so difficult to maintain, that's the reason give room for us as a scientists and the physicians to develop aging methods, which is anti-aging method, which is more acceptable for most of the public. So the most interesting experiment, and to me, this is still the most fascinating experiment in human history. It was done by a technique called heterochronic parabiosis. Heterochronic means a different age. Okay, parabiosis means living together. And the development was, the technique was first developed in the 1864 by a French doctor called Paul. And the idea was employed by Dr. Alexis Carrel, who is the father of the vascular surgery and the transplant surgery. And he proficiently the vascular vessel connecting techniques, and which was further being applied by Dr. McKay in Cornell University in 1957, okay, to study the aging problem. Okay, so the experiment is actually not very difficult. Basically, what you do is that you connect the two rats. One is an old rat, one is a young rat. You connect them, and you can do it a couple ways. One is connect the skin in the abdomen for 5 weeks, so which allows them to share the common circulations. And once the common circulation is established, it only takes about 5 days for the old animal to become young, and for the young animal become old. Okay, so the heterochronic parabiosis, to set up the common vasculature is going to take weeks. However, the actual effect of the heterochronic parabiosis is actually very, very fast. You can see the result in about 5 days. Okay. So to date, until now, heterochronic parabiosis is still the only rapid and visible aging reversal measures. Okay. So contradict to diet and exercise, which is very effective. However, they are by no means a rapid method. You can take a long time to diet before you see any results, and it's same as the exercise. And another thing which is interesting is that these are the heterochronic parabiotic experiments. You can see the animal just become younger, just right in front of you within 5 days a week. Okay, and the biopsies, which is you can see from the liver and from the brain and things like that from the animal, is also very clear cut. Okay. So with that, given that experiment in mind, so what really happened? Okay, and for centuries, from 1906, people have been trying to apply this very, very interesting animal experiments to the clinical practice. So the first thing is what really the procedure. So you have the pink rat, which is a young rat, and the blue rat is an old rat. So there are many ways they can share the common circulation. Okay, one is connecting the skin together. You can connect the artery and vein together. And third way is that you can really take out the blood from the old and infuse into the young animal, and vice versa. So there are many animal experiments being established. But what happened is they are sharing the common circulations, and basically they are sharing the plasma and the blood cells. Okay, so how can we do this in the human? Because the first question we need to ask is that how can we connect human together? So, and I think everybody is aware of the Siamese twins or conjoined twins. So you see this in the newspapers from time to time that two babies are linked together. It might be like this case is in the torso area. Sometimes they are connected in the head areas. So these are isochronic parabiosis. In other words, because they are twins, so they have the same age. So it's not heterochronic. It's not different age. So they are same age. So we call it isochronic parabiosis. Okay. Another way of human connecting to each other, I'm sure you've seen this before. That's called pregnancy. Okay, so during the pregnancy, the mother, who is the old donor, and the old subject, and the baby obviously is younger than the mother. So the only difference, this is a very classic example of a heterochronic parabiosis. The only difference of pregnancy from the classic heterochronic parabiotic experiment is that the pregnancy, the two subjects, they are very much different in size. The mother, the size is about 20 times that of the baby, which is normally, say, if we are giving the average weight of the last trimester will be 20 to 30 times. Okay. So this is the pregnancy is a symmetrical heterochronic parabiosis. So let us look at the result of the heterochronic parabiosis on the longevity of the mother. So there is a very interesting study done in the Siamese woman. So there is a very traditional group of people, and they live in a very identical, very similar lifestyle. So you can see that if the mother, the last pregnancy of the mother is age of 45, compared to the mother whose last pregnancy is at age of 35, you can see that the first category, the rate of that they will live to 80 years old will be 24%. And the second group will be 16%. In other words, that if the mother has the last child older, okay, the older they have the last child, the longer they will live to a old age. Okay, so this is a very classical heterochronic parabiotic data. So, but those two situations are you have to separate the young and the old subject, or with the natural circulations. But can we do it for a man or for a woman who is past the age of pregnancy? Or so how can we do it separately and to obtain the heterochronic parabiotic effect? Now, an intuitive way of doing the heterochronic parabiosis is this diagram. Okay, people always think that young people have some young substance. So, and this young substance, when we get older and older, those young substance, which is marked in yellow in this slide, will gradually to decrease to an old age. So, in other words, that people will think, if for this old animal who is have very little young substance, if we increase the young substance, then we will be able to obtain the anti-aging effect of this. The first people who carry out experiment using this concept is again Alexis Carrel. In 1916, what he did is he took out a chicken heart and put in a petri dishes, and he asked his research assistant to change the fluid outside of the heart, okay, from time to time. So with that technique, he was able to keep the chicken heart outside of the chicken body for about 34 years, okay. So with that, he come up with his very famous theory of the cell is immortal. Although this experiment was found probably not executed in a perfect way. However, this is a very early demonstration of the principle of the separated heterochronic parabiosis. And that was done by a chicken, okay? And the clinically in human, and I'm sure most of you will be familiar with this La Prairie therapy, which is done in Lake Geneva by a famous doctor called Paul Nihans, and since 1931. This, I think, although this treatment may be controversial, but I think for somebody in about 100 years ago already to have this concept of using the tissue extracts from a young animal or to correct the aging problem, I think Dr. Paul Nihans is certainly one of the pioneers in the anti-aging medicine. And his patients has a lot of famous people, including Winston Churchill, Charlie Chaplin, and the Pope, and Elizabeth Taylor, okay? So this is one of the most famous anti-aging methods, okay? And after that comes the placenta extract in Japan. And that was studied in 1971 from a Japanese company called Lanek, which is still doing the same product and supplying to Japanese doctors and Southeast Asia doctors the placenta extracts. Okay, again, this is using the young tissue fluid and to try to correct the aging phenomena. And the third one is a company called Ambrosio, and this company was started by a Stanford University student called Jesse Kamazin in 2014. And the business model is that he was able to set up a transfusion clinic, which he will collect the blood and from the young college students and transfuse those young blood back to the old rich people. Okay, that's the business model of the Ambrosia. Okay, so all those three methods has been done for many years, and I think there must be thousands after thousands of patients who has received the treatment. However, there are very limited objective clinical data, and in the same time, there are almost no publication, no real scientific publications about those early stage heterochronic parabiotic clinical applications. some of you may be thinking that some of the doctor may be thinking that, oh, we want FDA approved the GMP synthesis that, and I think that's easy said and done. Okay, and based on the statistics of the U.S. FDA, if you want to translate a technique from the laboratory to the clinic, from bench to the bedside, the success rate is only 8%. It's only 8%. So for those placenta extra from the sheep fetal lamb extras and the young plasma, I think they are able to sustain their practice for almost a century. I think that's already a miracle. And however, if they want to carry out actual clinical trials, the success rate will be only 8%. And I think what's been observed is pretty much follows these statistics. I think the whole field of the heterochronic parabiosis come to a new era in 2016. That's only about 5 years ago. Okay, you can see this paper was published in the September 23rd of 2016. It was accepted at that time. It was published in the November 22nd of the 2016. The paper is published by a couple who the lady doctor is called Irina Comboy, and the husband is called Thomas Comboy. This is a very famous anti-aging research team. They are based in the Silicon Valley area. Okay, both of them are in Berkeley. Okay, so what they do is that they begin to challenge this idea of useful substance. Okay, so what happened is that if you look at the couple of things that since there's no way you can connect young people to old people surgically or in other ways. Okay, so the only way you can really apply heterochronic parabiosis to in a clinical setting is basically by transfusion. Basically, you draw blood from somebody and then infuse it to somebody. That's the only way to do it. Okay. So now, if you look at this simple diagram, the left side is the young people. They have a lot of young substance, and the right side is the old people has very little young substance. And you will take out some blood from the old people and infuse it back to the young people, and take out blood from the young people and infuse it back to the old people. And although the amount added or subtracted is the same, since the base of the young people has a lot more young substance, so the effect on the young people of the young substance will come up with this type of result. Basically, the young people they will get a little bit older, and the old people they're getting same amount because the base is smaller, so the amount change is much bigger. So you are expecting the old people will become much younger if you transfer the same amount of the plasma to each other. Okay. However, surprisingly, the result come up just the opposite. Okay. So after you do that type of experiment, the young people actually become much older, and the old people only become a little younger. Okay, this is a very surprising result. And when I become aware of their results, I was in Cambodia, and it took me about weeks to restructure my idea and opinion about aging. Okay, so basically what happened is that instead of people normally think that is the young people has more young substance and old people has a little young substance, what happened is just the opposite. What happened is old people has a lot of old substance and young people has very little of the old substance. So in other words, that the aging process, in the aging process, which is dominated by the aging substance, is not dominated by the useful substance. Okay, although intuitively people tends to think that useful substance is dominant and the aging substance is recessive. It's just the opposite. Okay, so this is like driving a car. Okay, so you have on this picture, on the left side you have the brake, and the right side you have the the gas. So if you have the aging manure, which is the old substance, which is like a brake to the system function, then the right side you have the useful substance of the young substance of the accelerate the aging, accelerate the tissue performance. Then you can see that if you are stepping hard on the brakes, it doesn't matter how much gas you are adding, it's not going to work. Okay, so this is a very important concept. That is, let me repeat again, that the aging process is dominated by the aging substance. It's not dominated by the useful substance. So after the Conboys, the husband and wife team, okay, they published a paper, and everybody was all of a sudden brought to a very another paper published in a very small journal, okay, about 3 years before their publication. So this paper is published by American's first plasma exchange doctor called Dr. Kiprop. I'm pretty sure he's from Yugoslavia, okay. He's the first bodied plasmapheresis doctor in the US, okay. So at that time, in 2013, he already raised an hypothesis. He didn't do the experiment, it's just a theory. He's interested in using what he is familiar with, which is a plasma exchange machine, which you can look at it like a kidney dialysis machine. So he thinks he can use this plasma exchange machine to remove the inhibitory factors from the senior citizen and replace it with stimulatory factors. Okay, so to remove the inhibitory factors is not so difficult, but the technique is relatively mature. There are two ways you can do it. One is using the filtration method. The other way is using the centrifuge method. You have two ways to remove various molecular weight substance of various molecular weight. However, what do you replace? Those stimulatory factors or young useful factors is more arguable. Okay, so the first approach will be using the fresh frozen plasma from young people. However, the adverse reaction rate, allergy and things like that is about 25%, which is not acceptable in a non-disease setting or consumer medicine setting. So at that time, Dr. Kiprop already proposed that instead of using the FFP as the source of the young substance, he's suggesting people can use the 5% albumin or the IVIG or their combination to replace the FFP. And he also says that because the donor of those two medicine is 18 to 24 years old, and the adverse reaction rate is small, so that's what he proposed in 2013. And Irina published his paper on aging is dominant by the old substance, that he was brought to attention to Dr. Kiprop's hypothesis. So the two people teams up, begin to do a series of experiments. Basically, the concept is that if you have old people right here, then if you can do plasmapheresis in a weekly basis, so you can eventually remove the old substance and bring the older individual from an old state to change the internal environment of the old individual to a more healthy state. So you can do it in a slow fashion like this, okay, with the series of plasma exchange, okay. So similar technique was also employed in the Europe. A large company who is the manufacturer of the albumin and the IVIG called Grifols, and they carry class 3, level 3 clinical trials in Spain and the America. So they used a series of plasma exchange technique to treat early and mid-stage Alzheimer patients. And the experiment called AMBA studies. What they achieved is that this is the storyline is the experimental group who was received 6 whole volume plasma exchange Okay, and after they would receive a monthly low volume plasma exchange. And with this experimental group, the decline of the mental status will decrease, okay, as compared to the control group. The treated group will decline much slower, and the control group without treatment will decline much faster. And the rate of decrease, the rate of deterioration will decrease by 70%. So this is the level 3 A clinical trial, right? And this is the gold standard of all the plasma exchange technique. And with that result, they started plasma exchange clinics in Barcelona, and they are planning on setting up more and more of these plasma exchange centers to treat patients who have Alzheimer's disease in various countries. Since these plasma exchange with the machines, and like what I just explained, using the filtration and the centrifuge methods. So basically, they are using a physical way to do the exchange process. So we call them the physical plasma exchange. Okay, and some people may be wondering that the effect of the plasma exchange, are they due to the artificial plasma replacement fluid, such as the albumin? And according to Dr. Comboy, Rena Comboy, and she was clearly put it that when doing her experiment, if you remove the albumin, okay, it's not included, then you don't see much change in the experimental results. So based on Irina Comboy's experiment, it is likely the effect of the heterochronic parabiosis is due to the albumin alone. So that's very disappointing for lots of doctors, because I think most of the physicians are familiar with using the albumins in the clinical settings. However, this is not the case. Okay, you need to remove the aging substance. You cannot just simply adding the albumin into the system and expect the patient to become younger. So my background in doing anti-aging started way back when I was in University of Chicago. In 1992, I really began to do some experience on how to regenerate livers. 94, I was in CHOP, Children's Hospital of Philadelphia. We began to use bone marrow stem cell to regenerate cranial bones. And after that, since about 2003, I was able to isolate the ADSC from the lipoaspirates of the liposuction. And we've done tons of works trying to find a way that we can achieve some systemic clinical anti-aging effects. However, until 2016, almost everything is failed. And at that time, there was the rise of the Ambrosia. That was a company who buy blood from the college student, and we infuse them into the rich old people. Okay, so during that time, 2016, in a very interesting coincidence, I was brought to Cambodia by a friend who lives there to see a general there in Phnom Penh in Cambodia. Okay, and when I was there, I was surprised by that the population in the Cambodia is very, very young. Okay, and the reason is due to the communist countries era and a lot of the internal wars. And so most of the old people in Cambodia were killed. And so the Cambodia became the youngest country in almost the entire Asia area. Okay, so and what's most interesting to us is that because Cambodia at that stage is still during the developing stage. So, and I was told you are able to obtain the blood from a very young individual in the puberty around the puberty age at a very, very low cost. So with that given, so we started a project in Cambodia. So the initial idea was trying to using fresh frozen plasma, which obtained from the age of 15, and to do the heterochronic parabiosis. So like what was done in Ambrosia, because the younger the better, right? So if the Ambrosia people are using the FFP of a 20-year-old, and if I can use a FFP of a 15 years old, and I think intuitively we will get a much better result. Okay. So in the same time, Comboy published the paper. They were saying tell us that the aging process is actually dominated by the old substance. So it's not difficult for us just come up to the next stage of the solutions, which what we try to do is using a TPE, okay, plasma pheresis machine, and combine it with the FFP from a very, very young adult, okay? So this was our original recipe. And however, we started this recipe back in 2018, okay? We were able to start on this, okay? The results was immediately surprising to us. So the first thing is the TPE, therapeutic plasma exchange. The technique sounds easy, okay, but it probably is not so difficult in the Europe or in the States, because the people there are usually have a bigger vessel, blood vessels. However, in the Asia area, people tends to be small, the size are smaller, okay. So especially for women, okay, in Asia area, because the TPE required a 17 gauge needle in the blood vessel, so it becomes very difficult. And for a man, for men which is less than 6 years old, probably is feasible. But for women or for men who is more than 6 years old, because the vessel become more fragile and brittle, so the TPE become very difficult to perform. And frequently during the session, you need to change the IV port several times. So, and patients doesn't like it, okay? So the FFP15, the 15 age, the FFP from 15 years old is also not being accepted very well, because the Cambodia is very famous for AIDS, AIDS, okay? So most of my clients who is very highly educated, and once they know that the FFP is from Cambodia, they refuse to accept the fluid. So with that two issues, we are forced to change our plan. So for the plasma exchange machine, and after some calculations, we have changed it to become using a more easy method called bloodletting, just let go with the blood. With the FFP15, okay, because people cannot accept the natural plasma from young people from a country which has lots of AIDS. So we are forced to using a combination of the hormones from the HRT and a lot of cytokines and the artificial plasma replacement fluid. So we come up with some formulas like this and begin to treat our patients. For the bloodletting part, it's not difficult. Okay? For men, you can easily remove 200 to 300 cc of blood. And for women, you can remove 100, 200 cc of blood very easily. And this accounts for about 6 to 7% of the total plasma volume, okay? So it's not difficult. And for the supplementations, it becomes more difficult. So in this diagram, which shows how we do the intermittent plasma exchange based on the heterochronic parabiotic principle. So for the harmful substance, you can using bloodletting or using the TPE, therapeutic plasma exchange, to remove it. So that's easy. As far as the beneficial factors and the other adolescent factors, then we need to add up some hormones and some cytokines and some artificial replacement plasmas, okay? And that's the way we do it. So the first thing we encounter is we have a lot of allergies based on our biological products. And so we need to keep on changing our formulation to reduce the risk of the allergies. And during that time, we also, because it's very difficult to do the cytokine dosing, okay, so we are generating artificial iatrogenically cytokine storms. And some of the audience maybe we can recall that some of our patients, the blood pressure can drop, although they are not in, by definition, they are in shock, but however, their mental status and the perfusion is stays the same. So this is a very nerve-wracking situation, cytokine storm. So fortunately, at that time, in about 2019, okay, there's another professor called Tony Wiscorey from Stanford University. He got a big grant. He got a big grant using a very modern proteome analysis technologies. He gets samples from about 3,000 people, and they begin to analyze all these proteins inside the plasma. So with that, he was able to come up with the difference between the aging proteome and the young proteome. And what he see or what he observed is that most of the proteins in the old age and the young ages are the same. But there are certainly some substances will be lower in the young age and higher in the old age, and the other type, just the opposite. So he come up with a battery of around 10 cytokines, okay, and which he think is related to the aging procedure. With Tony Wiscorey's data, we are able to implement our formulation much more rapidly. And at that time, once the Tony's paper was published, we are able to come up with a very stable formulations. So from the third quarter of the 2018 until the first quarter of the 2020, so we are able to perform around 1,000 plasma exchange, okay, in Kuala Lumpur. And at that time, the acceptance rate begin to become better and better, and we are very happy about it. And but we are forced to face another new issues. Okay, so all of our patients are pretty much, I would say, they are happy with the result. So because our retention rate usually maintains over 50%. However, the question will usually come from the patient is that they will tell us, how long do I have to continue to do this procedure? In other words, we are lacking of a practice guideline. Okay, we don't have a guideline to do this procedure. We know people, if people can accept intermittent this type of plasma bloodletting and plasma infusion, they can accept the procedure, but they don't want to continue to do this on a monthly basis or bi-weekly basis for the rest of their life. So we do need to come up with a practice guideline. So okay, so with that, that was about last year. So we begin to design a serial experiment in the laboratory, which can measure the activity of the plasma against different cell types. And using these laboratory results, we can use it to guide the clinicians about how to perform the plasma exchange. So let us use this diagram as an example, and let me explain to you about how this plasma toxicity and the activity examination was done. So the x-axis is the mixture and of the percent of the mixture of the human of this patient's plasma, which is 100% right here. The 0% is the purely control, which is the standard laboratory culture media of the stem cells. Okay, so you can see that if we take the patient's plasma and to the laboratory and give it to the stem cells, and most of the stem cells will not survive. So the number of the stem cells start with in this red colored dashed line right here. So 1 week later, all the stem cells will die. Okay, so in other words, that the plasma of the obtained from an old patient is very toxic to the stem cells, as compared to what was in the what was commonly used, the culture media used in the laboratory. You can see that number of the stem cell will increase from 0.23 to 1.0, okay? So they have a rapid increase. And the interesting part is that the optimal growth of the stem cell doesn't occur at the laboratory media. It's not from the patient's plasma either. What the optimum stage usually comes around 25 to 50%. In other words, the best way to culture this stem cell is not using the culture media in the lab or from the or using the plasma from the patient. The best way to culture the stem cell or the best way to activate the stem cell is actually using a different mixture, okay, different mixture of it, okay. So this is the plasma toxicity test, because the stem cell will die, and the activity test will comes up with the best proportion, which is about in this case we are around 15% of the patient's serum, okay. So that experiment being designed and established, which took us some time, okay. So we are able to come up with this type of diagrams for patients for after each plasma exchange sessions. So you can see this patient, the blue line was his result from April 30th, and the orange line is about 1 month later, okay, 1 month later, and you can see the toxicity was begin to decrease. You know, that you only need only 5% of the patient's plasma is toxic. 95% pure will be toxic. But if it's as long as you give the patient's plasma 5% of the standardized culture media, then it becomes viable for the stem cell in the lab. So you only take about 2 sessions. We can improve the plasma quality of the plasma from the blue line to the orange line in merely 2 sessions, okay? So once we have these experiments, we are able to guide our clinical, guide our formulation clinically, okay? So, and with that, when we continue with this technique in hand, we are able to use all the data, continue to optimize our treatment program. And this involves a lot of calculations. We need to calculate these are the beneficial factor diffusions to a cell, okay? And we also need to calculate the bad or aging factors, which is produced by the cells and which will diffuse into the capillary. Since we need to do some of the calculations. And we also need to account for the volume of the intracellular fluid, the extracellular fluid, interstitial fluid, and the intravascular fluid, okay? And eventually, we come up with more and more data and more effective way which can correct the plasma. And at the end, the last will be, we need to also account for the half-life of the cytokines, because the old substance, usually their half-life, because it takes years for them to aggregate. So the half-life of them are usually much, much longer than the cytokines, okay? The beneficial useful substance, the half-life is much shorter. And when you want to dose the patients, and you need to account for the different half-life. You cannot do them using a one-part therapy, okay? So the next question will come is that how long does the effect will last? So in this case, because we have this powerful technique to examine the patient's plasma activity and toxicity, you can see after the main area, we repeated the same exam about 2.5 months later. Then you can see that patient's plasma quality, activity, and the toxicity remains the same, okay? So with that, we come up with some findings, okay? The first thing is the old plasma cannot support the stem cell alone. The second one is that the plasma can be corrected in 2 to 3 sessions. The third one is that the percent of the improvement is much bigger than the percent of the bloodletting, okay? And the fourth will be the effect can last up to several months. And finally, that all these things are patient dependent, and you need to do the dosing using a time dependent method to achieve the best results. So since we are using a combined method of bloodletting and there's some chemical supplements, so we name this type of plasma exchange as a biochemical plasma exchange, which is different from the plasma exchange using the machine, which that's called a physical plasma exchange. Okay. So again, we need to examine the question, like the arena combo, is this due to the albumin? So it's very simple. We bring the albumin to the lab, okay, and then you can see that this right side is the 100% albumin, okay. You can see the albumin is actually very toxic to the stem cells. So very easily we can see that the effect is not due to the albumin, which is toxic to the cell alone, okay. So what I'm trying to tell our audience is that the plasma, the heterochronic parabiosis can be done clinically, but it's not. You need to use a compound formulation, and you cannot use just simply one type of medication such as albumin or IVIG to get the result. Okay, so right now we perform our plasma exchange, biochemical plasma exchange in two phases. One is the intense phase, and after that will be the maintenance phase. Intense phase, we will do 3 vials of transfusion, so every 2 weeks, and each day will be 3 hours. Okay, so and for each vial is about 50 cc. So every 2 weeks. So in the first month you will have 3 sessions. Okay, so if you do the plasma exchange today, you can do another one in two weeks and another one in 2 weeks. So the 3 sessions will be finished in 1 month. Okay. And for the maintenance phase, then you can do it every 3 to 6 months, and it will be performed at the lower volume. Usually you just need to infuse about 2 vials, so it will take shorter time as well. Okay. The important thing is that other than the plasma exchange, you need to also deliver some of the cytokines, okay, based on the patient's blood test. And these are our proprietary technologies. And if you are interested, I will tell you more about this in a more private setting. Okay. So now let us look at some of the clinical examples. So the first example is a patient who had a stroke recently, and the patient is a very successful businessman who does business with the US and with a big factory in China. Okay, and he's a friend of mine, and he received 1 plasma exchange session about 1 year ago, but he has to return to China because of the COVID-19. Okay, and so he once he went back, and then he was happy because he was able to do very good business with the US. Then he returned to Taiwan earlier this year. Okay, and he come back to our clinic, and we did the first blood test on the second blood test on him. So we see the left upper corner. We see this is his plasma quality examination. You can see that the quality, his plasma was not doing very well because only 50% of mixture of his plasma, 50% of his plasma and the 50% of the culture media were able to sustain the stem cell culture. Okay, so which is quite different from a healthy plasma profile, which is more like this one. Okay, more like this one. So when we see this type of toxicity in his plasma, I call him up immediately, asking to come back to the clinic for further examinations. And when I called him, he told me, he said, "Wow, how do you know I'm in the emergency?" I said, "I didn't know you're in the emergency." He said he just had a mild stroke. Okay, and half of his body cannot move. Okay, so fortunately, he was he was aware of this type of therapy already, and he did pretty well. He was discharged from the hospital in 6 weeks, and after 6 weeks, he come back to the clinic and to get this plasma exchange therapies. And you can see after a couple of sessions, the quality of his plasma begin to improve. Okay, begin to improve. Okay, so but he was very aggressive because he wanted to try to return to his normal state, his normal physical state. So he was very aggressive, and we did probably 10 sessions within about 3 months on him. Okay, and the result is that you can see that he was half of his body was not able to move previously, and now he is able to play tennis, and it's very difficult for you to tell which side of his body has a stroke. Okay. The second case is a very common situation we see in Taiwan, okay, which is called diabetic chronic kidney disease. In other words, these are diabetic patients and not type 2 diabetic patients. And once they have the diabetes for more than 10 years, usually the kidney function begin to deteriorate, okay. So this is a patient who come to us in the beginning, okay. So that's her initial quality of the plasma, okay, which is not bad as compared to the previous case, which is very serious. It's just very toxic, okay, which is not bad, okay. So after the several treatment, his quality of the plasma continued to improve. And you can see on this mid-center lower graph, his plasma was able not only to sustain the culture of the stem cell. Here you can see he was actually able to activate the stem cell growth of the stem cell, begin to increase, okay. So at that time, she got carried away, okay. She got carried away with her blood sugar and things like that. So we begin to increase the interval of her treatment and decrease the dosage on her plasma treatment. So this is the end result of her treatment in our clinic over the past about 5 months, and her eGFR was able to increase by 10%, okay, and the creatinine was decreased by 10%. The B1 was slightly increased, okay. So you can see that she's actually getting some pretty interesting. I think it's a pretty fair result over the treatment, okay. But if you look at this data even more carefully, you can see that her eGFR was actually increased by 20% in the intense phase, in the early treatments. Okay, it was increased by 20%, and the creatinine was dropped. Okay, or maintained the same. So the B1 was dropped by about 30%. Okay, in the initial intense treatment phase. Okay, and because of the other reasons, we cannot continue on the intense treatment. So once we decrease the dosage and increase the interval, and her creatinine and the eGFR begin to decrease. Okay, the eGFR begin to decrease, which is not a good situation. We are talking to her this coming week and to see what she want to do and in the future. Okay, another case is 93-year-old lady. Okay, she come to us because of frailty and the sarcopenia. She has become very weak. Okay, and the son is very very successful business people. Bring her to us. They want her to improve her conditions. Okay, so this is one of our earliest patients. She started her treatment probably back in early 2019. So after this is several sessions, she was able to get a pretty good plasma profile. Then with continuous treatment on a monthly basis, we were able to make her plasma to become twice as good, twice better than the performance of the culture media as shown in this diagram. Okay, and if she's increase the interval of the treatment, then the quality will drop. But however, it still maintains in a pretty stable position. Okay, And this past about at the end of 2020, because of the fear of the COVID-19, the son decided to withhold, postpone her treatment for 6 months. Okay, so and then when she come back to us in July, okay, in July 21st, you can see her plasma is still able to maintain the stem cell growth, still able to maintain the stem cell growth, which is about the same effect as the culture media. So with all this data, we can also see that her hair has this some interesting phenomena. Okay, so the left side, this is the brown part, is from the dye of the hair. Then these are the white hair grow out, and the black hairs coming out after the treatment. You can see this black, white, black phenomena, which cannot be done other ways. Okay, there are also many other cases, such as improving virility, improvement in presbyopia, and some people regain their menstruations, and the diabetes get controlled, and some people has pancreatic cancer after surgery. It was very weak. He's actually from Malaysia, okay, and we have some pancreatic patients, cancer patients in Taiwan as well, who was in the hospice, and after some treatment, they were able to be discharged from the hospice, and he lived for another 2 years, and passed away. And this guy who is pancreatic is still alive and well. And some asthma patients also got the pretty good improvement in their MMSE scores. Okay, so and as far as formal clinical trial goes, we can the gold standard is the MBAS trial. Okay, that's tell us the decline in the MMSE score is 71% less than the control group, which is patient without the MMSE, without the plasma exchange treatment. So this is the gold standard MBAS trial. And other trials also able to show that they are able to increase the EGFR, okay, by 10% after 1.5 years of treatment. And remember, we are able to accomplish the same result in only 4 months, okay, in only 4 months. So this is a big market and big application for the diabetic chronic kidney disease. These are for the immune functions, improvement in immune functions. And please don't forget, we also have the longitudinal data on the Siamese woman, which is which studies the effect of the pregnancy on the longevity of the mother. Okay, this is also a very reliable clinical data. Okay, so now let us summarize all these informations in a scientific way. Okay, so this diagram on the x-axis is the age, and the y-axis is the growth or growth potential. Okay, so you can see once people is born, then the growth potential go up and until puberty, then come down. Then at the same time, after the puberty period, people's reproductive potential go up and then come down at the age around 40, 50. Okay, and based on the theory of evolution of the Charles Darwin. Okay, so if a species want to survive, okay, you need to conserve the energy or the resources. So based on this theory, once the species reproductive age has passed, the repair capacity of the species begin to decrease. So when the repair capacity begin to decrease, the disease will begin to go up. Once the disease reaches some certain extent, then the gray area shows that people begin to get ill and die after that. Okay, that's the circle of life, which is designed based on the theory of evolution. Okay, so what we are trying to do is that with the modern medicine, so we are able to manage the chronic disease much better. So we are try to elongate, shift this disease profile to the right. In other words, we try to make the people live longer we're trying to make the patients live longer who have diseases with modern medicine. This is what modern medicine accomplished. Okay, so right now at the current state, age of 2020, so that life are becoming into 3 stages. One is a healthy health span, and after reproduction age, people begin to go into some less pre-disease state, and after that 70, 80 years of become into a disease state. So what we are trying to do here is we are trying to improve the repair capacity, okay, or decrease the risk of the disease, okay. We're trying to do that so we can shorten the disease, the time people is ill, and try to increase the pre-disease stage. And if it's possible, if we continue to do that, we hope to get to this point that we are able to increase the health span of the species longer, or until probably 70 or 80 years old. Okay, that's what we try to accomplish. Okay, so let's come look at the aging process from the beginning again. So now you have the genetic and the epigenetic theory of aging. Then the best way to do that is to prevent aging is diet and exercise, but which is very difficult to do it. Okay, and if you cannot maintain diet or exercise, another way is that you can perform the plasma exchange. Okay, either using the physical plasma exchange or the biochemical plasma exchange. Then you can stop all these disease aging processes. So in summary, the heterochronic plasma exchange originally is just an experiment, and it's reverse aging by reconditioning the systemic milieu to the useful state of the past. Okay, and there are 4 ways we can do this now. One is the natural way. Natural way is you can remove the aging substance by menstruation, and you can gain the useful substance by pregnancy. And you can do it biologically. You can remove the aging substance from using the bloodletting and gain the useful substance from the young FFP. Okay. The physical way, you can remove the substance using the machine by centrifuge or filtration, and you can using an artificial plasma replacement. Okay. The biochemical way, you can use using our combination of the bloodletting and some of the binding proteins, and remove it and then supplement it with time-dependent cytokines. Okay, and the natural way you can do it at home. The biological way is very cheap, but it's very hard to get some young plasma. Okay, some young plasma which is clean and safe. This is very difficult. So in our practice right now, we are focusing mostly on physical plasma exchange and the biochemical exchange. A physical exchange is very fast, but it will only last for about 14 days. And it has a lot of condition and a lot of constraint. You need to get a big van to do this, okay? So this is good for men who is less than 60 years old, the physical plasma exchange. And for other people, I think biochemical exchange, which is mild and long-lasting procedure, which is probably more suitable, okay? And the setback is that you need to come to clinic for multiple times, and but you can get the result in a progressive fashion, which is fairly good, okay? The clinical result of the heterochronic plasma exchange, you can increase the virility. Now you can increase the immunity. Now you can reduce the insulin resistance. This is for diabetic control. Now you can improve the cognitive function. This is good for people who has early Alzheimer or has a stroke, okay? And you can improve the patient who has chronic renal disease, either from genetic reasons or from the diabetics. And then lastly, we can use this to prevent cancer recurrence and the metastasis. So what has been said, right now we have a one way, we are using the stem cell as our treatment target. We have a formulation. So we are expanding the stem cell therapy into the EPC therapy and the cardiac muscle cell therapies. So this is what we are trying to do. And we also have different formulation and continue to be developed. Okay. And we're also developing technologies which can use the plasma exchange procedure to regenerate and rejuvenate the internal organs externally, okay? And business-wise, we are trying to set up these plasma treatment centers in the Southeast Asia and the Greater China area. Okay, and originally we are hoping to set up about 10 sites, 10 plasma exchange sites in 2021 or this year. But because of COVID-19, we hope we can do it in 2022. Okay, so the program was pushed back by 1 year. Okay, but I hope the COVID-19 will ease up very soon, so we can obtain our business goal of our business expansion. That's what I just said in the beginning, because to prepare for the formulation for the cytokines and those plasma, the window are very small. In other words, if you use the cytokines too much, you're going to get a severe side effect, like a allergic reaction, or sometimes you might get into shock. Okay, and in the same time, we also need to avoid iatrogenic errors. People can, when you are formulating those complicated infusions, you need to be very concentrated, and you need to do a lot of calculation to obtain the formulation. Okay, so for that, we are developing automated plasma diagnosis and compounding device. Okay, so this machine is pretty much ready. It should go on commercial in the end of this year. Okay, so what we are trying to do is you have a patient here, then you're going to draw the blood, 150 cc to or 100 cc of blood, and send it to our lab. So we're going to have a robotic machine will do the plasma diagnosis, and this, based on the result of formulation for the patient, send out, and that will go to a compounding machine, which will formulate the plasma and to be reinfused back into the patient's body. Okay, using a vein. So this will be forming a service circle. And if you are interested in the contents of this talk, and there is a Chinese book already been published, and the English edition of the book will coming up in about 6 weeks. Okay, and you can contact our host, Mr. Suho, and to give more information about this. Okay, with that, I think this will come to the end of this talk, and I'll be happy to entertain any questions if there is any. Thank you.
Does it have to be people with very severe diseases, or it can be done by someone who is fairly healthy in the mid-60s?
Okay. The question is, is this procedure needs to be done for people who is very ill, or you can done for people who is healthy in the 60s? I think you can do. This is a very powerful method and a very scientific method. And for people who is sick, you can use it to manage those chronic disease. Okay, and for people who is healthy, you can use this as a way to do anti-aging, so people can stay young, stay young and stay healthy for a longer period of time. Yeah, you can use it for both. For our patients, I would say probably 2/3 of it has some type of chronic disease. Okay, and then 1/3 of it is coming in just purely for anti-aging or health span extension purpose.
I see. So would that mean like how many sessions as for maintenance, or?
Yes. So for people who is coming in for not for disease purpose, basically they only need one treatment sessions, one intense phase sessions. Basically, that's around 9 to 10 vials of the plasma, which each is 50 cc. And after that, they come back every 6 months for another checkup. If they're doing well, if they don't need anything. If they are doing a little bit worse, then she can have a booster for probably 100 cc, 1 or 2 vials. That should be enough. Yeah.
Okay, thank you.
Sure.
Hi, Doctor.
Hi.
Very wonderful lecture and
Thank
very
you.
exciting experiment.
Thank you.
No, that one is, we call it like an allograft,
Mhm.
allograft stem cell, right? I mean, it's like an allograft, not autograft. So supposed to be the donor is from the young ages.
Okay, let me try to explain this. Okay, we don't use any donors anymore. Okay, because what I say, originally we hoping to using a allogenic type of plasma, but allogenic plasma, because we are a small company, we are not like big pharma. You cannot really manage the quality that well, and people is also gets pretty nervous about the source of the plasma. So what we are doing is, alternatively, we are using, based on the examination of the allographic plasma, we come up with a formula. So we are using biomedicals. Basically, we're using drugs such as albumin, such as IVIG, such as different GCSF, oxytocin. It's a mixture of drugs. It's almost like a concept of TPN. Okay, TPN is for malnutrition, right? So this is like a TPN for aging. Okay, with the formula given into the plasma, we can recondition the patient's plasma into a more useful state. Okay, and this is not just what we are saying. We are seeing this in the laboratory, and the improvement is more than, can be up to about 2,000% younger, 2,000% younger, 20 times younger. Yeah.
Oh, I mean, this is just only like for the first time we just draw our only blood, our own blood.
Yes.
This is auto, and then put it in the machine, and then the machine will check it by itself.
Yes.
Oh, okay.
Yes. You got it. Yeah, and once the machine check itself, it will come up with a formulation. How much this plus how much what, right? They were doing the examination with different ratios of different medicines, and we'll come up with a formulation. Let's go to another machine. Another machine will mix them based on our SOP, and to come up with the formulation for the patients. Yeah.
Oh, okay. So every time we do the plasma exchange like that one, so we have to withdraw our own blood.
Yes, for testing. For testing. Yeah.
Oh, for testing only. For this, for example, for the second plasma exchange, and then we don't have any drawing our only blood, or just the machine have their own record memory on it.
Every time we pretty much draw the blood every time, but we draw about 100 cc of blood every time. Yeah.
So how much blood cc you draw for the exchange?
The test. 100 for women, and 150 cc for men.
Oh, okay. Usually it takes time. The progression, you mean, is every 6 months or 3 months, like that?
Yeah, for healthy people, you just do it every 3 months. It's fine. Yeah. For sick people, then you really need to. You finish like 10 vials, you do another test. Then you, based on the test result, you decided on what to do. Okay. Most of the time, because the patient is happy about the improvement in their renal function, is improvement, happy about the improvement in their dementia synthesis, they continue on the process. So, I mean, although what we're recommending is you just come back every 3 to 6 months. However, in fact, most of our patients, they're up to do it on every 6 weeks or even monthly basis. Yeah. If they can afford it, yeah.
Is there any have you ever come across any side effect aside from the allergic, like anaphylactic, like that, or something dangerous? Let
me tell you something. Yeah, because allergy was our original nightmares. Okay, we have about 20% allergy rate. Okay, now it's very stable. Now the new formulation now is probably 3% allergy rate. Okay, so. But interesting that some of our early stage patients who has the allergic reaction, they always, a lot of times they will ask us if they want the original formulation. They think the improvement outweighs the allergy reactions. So even they have an allergic reaction, they want the original formula, which is much more potent. Okay, so this is very interesting to us because you see the patient has allergy and they come back and say, hey, I don't mind. I want just give it to me once more. Yeah, it's very interesting. Yeah.
Okay. Yep. Thank you so much. Thank you.
Well,
Hi, Dr. Pen. It's Alice here.
hi, Alice. How are you?
How are you?
Good, very good. Yeah.
Okay, very interesting. So I see that there seems to be, a shift in our original concept is to infuse more of young instead of old. So now that you said that it's more of an old substance that is causing some of these old diseases, but now I see the new protocol, less blood is being taken out. So I just want to understand why. Don't you think by removing more blood would be better?
Yeah, because that's a good question, Alice. Yeah, so very good to see you again. If I don't give a talk, you don't even say hi anymore. Yeah, because everything is based on the laboratory test now. Originally based on calculation. We don't really have an objective way to guide how much blood we take. But with this new test coming out, the data come pulling out. Okay, we found that we don't need to take out that much blood because it's a lot of technology in the formulations. Okay, I mean, because of the time constraint, we only have about 90 minutes. I can tell you more on this, but we are adding new technologies. So the plasma itself can actually circulate in the body, and part of it is removing some of the old substance, but it's different mechanism. Yeah, it's a different mechanism. Yeah.
So would I just say that because I'm trying to understand the logic. Maybe by not taking too much out, whatever existing stem cells that's circulating in the blood, with the exchange, then whatever dormant stem cells will probably be activated. So
because the number of the stem cell in the plasma is very little, I don't think that's the important. But the issue is when the new data come out, okay, there are three compartments in the body fluid, right? One is intracellular, right? The other one is interstitial. The third one is the intravascular, right? Okay. So the new data just came out, which is very, very interesting, is what we used to think that the intravascular volume is all the cells in the body and the organs share the same intravascular volume. So that's given, okay, but you have same blood circulating around the body. What's surprising is the interstitial fluid is also shared by the whole body, okay? So intracellular, because it's in the cells, but it's organ dependent, but the extracellular fluid actually only two compartments, and that's been circulated around the whole body. Yeah. So what we are trying to do is just everything is guided by the lab data, and what we think is that because of the improvement in the intravascular fluid, which will lead to the improvement in the interstitial fluid, and this will let the stem cell, all the adult stem cells reside in each individual organs to be reactivated. Okay, so we are not reactivating only the stem cell in the blood. We are reactivating stem cell in the liver, in the brain, in the heart, and in the joint, in the disc. Okay, and we are seeing people who has a back herniated disc, which has back pain for many years. They don't want surgery. They improve after 3 plasma exchange sessions. It's just very interesting. And people also had like degenerative macular disease, or they also get an improvement. Where people has degeneration from the high eye pressure, since that the retinal degeneration, they just feel their eyesight is getting improved from this. Yeah. So it's a bit different from the old concept. The old concept is based only on the 2 animal model, right? You have one old animal, one young animal, you exchange the fluid. So you have to remove fluid. But we are with the lab test, available now, we are able to use a lab test to optimize the treatment and the dosage, okay, the half-life, and that's what we are doing now. Yeah. So it's very intelligent now. Yeah.
But when you say the lab test, is the lab test as in from the blood investigations, or what sort of lab test are you referring to?
The lab test I'm talking about is the plasma toxicity and the activity test, and that's been done. Will be used to test that. For me, I can't hear.
No, the graph that you were showing me, the one with the green line, the blue line.
Yes,
there's
yes.
something new.
That's the key. That's the key. That's the guideline now. That's the clinical guideline now. So basically, what's been done in Kuala Lumpur before, when we were working together, since that was the old method where you don't have a lab test to guide it. So it's almost like a one method for all. And now it's very individualized now. Okay, so people will be taking out, some people 60 cc of blood and then infuse 100 cc. See, everybody's different now. Yeah, it's a lot of more variety now. Yeah.
Interesting.
All right, thank you,
Yeah.
Dr. Alice. And Dr. Penn, I have a question from an audience. Jolan is asking, during the process of plasma, will it be possible that some good materials in blood will be taken out as well?
Yeah, because yes, some good material will be taken out too. But you see, I mean, this is the popular science talk, because if you look into all these in more details, by the thermodynamics, the definition, okay, then the good substance usually can come back very quickly. So like when you're doing the therapy, some of the cytokines will be taken out, but the good cytokines will come back very quickly. The bad substance will come back very slowly. So basically, we're doing something called like the time arbitrage of the plasma. Okay, it's hard to explain, but anyway, I hope this explains the good substance. You can take it out, but it can easily be replaced. Okay, the important thing is the bad substance. How do we remove it? But once it's very hard to remove it. But once you remove it, you can last for a long time. You can last for a month. I personally really think, I mean, if it's a healthy individual, you take out some old substance, it will last for years. Okay, it will last for years. Yeah.
Thank you, Dr. Penn.
Sure.
And I have a question for myself, for my friend. Further to your explanation just now, you mentioned that some patients have a chronic back pain or spine ache. But what if my friend, 35 years old lady, she has a chronic back pain, but it's not due to aging, but a serious trauma from previous accident? Would it help?
The trauma is aging, okay? Because trauma, if you have a trauma, then you have a degeneration. This is the same mechanism as aging, because aging can cause chronic inflammation and fibrosis. Trauma also causes fibrosis, okay? So if it's from a trauma, back pain from a trauma, I think is indicated.
Noted. Okay. Thank you. And we have Mary Lowe is asking, how does this procedure compare with bioidentical hormone replacement therapy?
Okay, the hormonal replacement therapy is very limited to what is related to reproduction, okay? And what we are doing is a more systemic level. We do everything in a more systemic level. We're not just gearing just only treating what is related to the ovary and the things like that. Yeah, so you can say the HRT is a small part of the plasma exchange procedure. Yeah.
Thank you. And one question back to audience 181726. Sorry, you were asking this earlier. Where do you get the plasma from?
That's what I explained. Because usually because I was trying to tell people that we don't get the plasma from anybody now. Because we used to try to get the plasma from the young people in Cambodia, but nobody wants them. Nobody wants them. Yeah. So what we do is that we get the plasma. We formulate the plasma using FDA approved biological and some of the cytokine drugs now. So it's all licensed. It's just like TPN. Everything is from a GMP. Yeah, everything is legal. Yeah.
Thank you, Dr. Pen.
So can you just say that this is somewhat like a synthetic plasma?
Yeah, you can say that, whatever, you know. Yeah, we'll name it Alice Plasma. How about
I don't mind.
that?
Dr. Pan,
Yes.
I do have another question. Nowadays, they just use the plasma exchange for treatment for the
For
COVID-19.
what? Yeah, COVID-19, yes,
For
yes,
the COVID-19.
yes.
What is your opinion about this one for using your kind of machine?
Yeah, it's different, okay? The
recommend
COVID-19 is you get the plasma from a patient who is being infected with the virus, and who has a lot of
Yes.
antibody against the virus. Okay, and if you get a plasma from a patient who has been infected, then you might get an advantage of some antibody. So I think it's a lot of data out there. People are trying to do clinical trials on this, and I personally think there's nothing wrong with that. But for what we are doing is a little bit like what I just said, answer about the question about the HRT. What we're doing is a lot more general, okay, much more fundamental. The easiest way to look at it is that we're trying to reconditioning your the environment inside of your body and make it more suitable for the survival of certain cell types. We can do that now, okay? So in other words, for people who has for example, just say the trauma to the joint, then obviously what needs to be optimized, the plasma needs to be optimized to culture the stem cells. But for people who had a stroke, right? So then we need to formulate the plasma and make it better for the neurons. So we can do that now, you know, with the new technology. Yeah.
Okay, thank you.
Sure, you're welcome.
So does that mean that now every condition can be customized to each?
No, we are not doing, I can't say any condition, but we are using the most mature way is based on the stem cell. So for degeneration, for repair, for fibrosis, for inflammation, which is good, okay? But eventually we're developing the next one on our map coming up soon is the plasma therapy for the coronary artery disease, which is optimized for the EPC cells, for the epithelial progenitor cells, okay?
Yes, Dr. Pen, I was wondering if the procedure can help regrow some damaged areas, for example,
Yes.
like a torn meniscus or a,
Yes.
Okay, that's good.
Yeah.
The degenerative
Yeah.
joints and
Yeah, just think of it, okay? Because I'm a physical chemist, so I'm not an economist because we do a lot of modeling, okay? Think about you have a damaged disc, okay? So how are you going to fix it? It's relying on the circulation, right? It's still relying on the circulation to bring up nutrients and things like that. So if the nutrient, the plasma can support the local stem cell to regrow. So then it will assist and accelerate the recovery, okay? And that's basically the situation, yeah. So,
that's good.
Originally we were very surprised. We thought it doesn't work for the disc. It just came out for the disc, and people had a back pain, they just get better, then walking better. We have a 90-year-old coming in with a cane, okay, and after 3 sessions, and he came to our clinic, for some cytokine supplementations, and he was asking us, "Where's my cane? Where's my cane?" And we were laughing because we said, "You came without a cane, So it's very interesting. People they don't remember.
Yeah.
They come with a poor memory. Now they all of a sudden they remember things. They say, "Hey, where's my daughter?" So it's just a lot of interesting things is happening. Yeah.
Dr. Pen, my husband has a middle ear problem.
That's a hard one. That's a hard one. Yeah.
Hard one, huh?
You
The
know,
smallest nerve.
the heavy hearing. Yeah, we don't see
Yeah.
much improvement on that yet. I don't see that. Yeah.
Okay. Thank you, doctor.
Yeah. Sure.
What if you have a mechanical dislodged disc, like prolapse disc on your spine? Do you think that's gonna?
Yeah,
help?
that's what I'm saying, because trauma is degeneration. I think it might help. It might help. Yeah, that's what we see. Yeah.
Prolapse disc is because it's physically, the disc is protruding out and probably compressing
Yeah.
certain nerve. So
What we see,
mechanically-
you see, I understand that the protruded disc is different, right? Mechanically, no, you cannot, right? You cannot squeeze it back into the intervertebral disc. You cannot send it back there. But what we see is that because the disc itself is right here, is no blood supply, but you have the blood supply coming in from up and down. Okay, so if you improve the circulation and the plasma condition, the disc itself becomes stronger. At least you will prevent it from keep on getting worse. Okay. Yeah, that's what we see. Yeah, and if you do combine this plasma exchange with a little bit of physical rehabilitation, I think it's good. Yeah, some of them just get good clinical results. Yeah.
One more question.
One more, last one, Alice.
No, the interesting part I saw is the hair growing back black in the 94-year-old.
Yes, yeah,
Had,
yeah.
this.
Well, a lot of patients have they have a grayish hair coming back and then become black hair coming back. Yeah.
Okay, that's going to be huge because a lot of people.
No, I don't think it's very expensive treatment for gray hair. Okay, you can just use dye, a natural dye. Okay.
But you'll be surprised. Some people are willing to spend money to get back their black hair.
Oh, is that right? Yeah. Anyway, if you have one, just refer it to us. Yeah. Okay.
Hi, Dr. Pen. Irene is asking, I am a wellness coach. I have one patient body is deteriorating and have nerve problems due to the chemical from the body. How can this help?
Chemical from the body. What do you mean by chemical from the body?
The toxin metal.
Oh.
Toxin metal is
the heavy metal, is that right? Yeah, we can. Yeah, we can try to do that, but we need a special formulation for that. Yeah, we were adding some special formulation to do that. It can be done. Yeah.
Doctor,
yes.
I do have the last question, please.
Okay.
If you compare about this plasma exchange to the mesenchymal stem cell, you know that we can extract from the fat or from the umbilical of the fetus, and then if you compare that, what's the result?
Because I've been doing mesenchymal stem cell from the fat and cord for over 20 years, I can tell you, I think I fail for me to answer you, okay? The effect of the plasma exchange is probably at least 10 times better than the mesenchymal stem cell transfusion, okay? But for local treatment, local joint problem, local treatment, okay, local injections, or for like a facial scar or local injuries, things like that, direct injection of the mesenchymal stem cell is good, okay? But for systemic effect of the systemic anti-aging effect, I think plasma exchange is much, much, much better. Yeah.
Oh, I see. Oh, how about for the disease type, kind of like the degenerative disease like that, for the Alzheimer?
Yes, because I've been in other talks, I can tell you more about my experience in stem cell transfusion. Because once you infuse the stem cell, right, into the vein, you will go to the right heart first. And after the right atrium, go to the right ventricle go to the lung, right? But the capillary, the small capillary of the diameter of the pulmonary capillary is about 5 micron only, 5 micron. But the size of the mesenchymal stem cell is 15 microns. So most of the stem cell infused into the vein will end up in the lung, okay? So mesenchymal stem cell infusion is good for pulmonary fibrosis, okay? For the lung degeneration. But for the rest of the body, because the mesenchymal stem cell infused cannot reach that, cannot reach that part. It cannot go to the brain. It cannot go to the bone. So the effect is indirect. Okay? I'm not saying a mesenchymal stem cell is bad. I'm saying that it cannot get there. Okay, it just simply cannot get there. Okay, so if it's a lung problem, okay, liver problem, yeah, we can try. But for other part of the body, the mesenchymal stem cell infusion is not very effective. But if you can, yeah. But if you say for somebody who had a heart problem, you have a long needle, you can infuse, you can inject the mesenchymal stem cell to the heart. That's okay. Yeah.
Okay.
Yeah.
Okay. Thank you so much, doctor.
You're welcome.